Hello everybody, welcome to Omega Toppers Academy. Today we will be discussing the concept of electricity. This electricity concept is discussed in the Karnataka state syllabus for 10th standard and the CBSE 10th standard. We have more videos coming on this topic. Check out our channel for the chapter wise playlist. So now let's get started. Electricity, as soon as a student hears, they find that, oh, it's going to be difficult. No, it's not actually difficult. Electricity is a concept which we use in our day-to-day lives. So what is this actually electricity? So here electricity is nothing but the flow of electrons in a circuit where the circuit is a closed loop. So what is this closed loop? The closed loop is actually made up of a conductor through which the electrons will flow. So mainly we can define the electricity as the flow of electrons in a circuit. So what is this circuit? A circuit is a closed loop made up of so many components called resistor, battery or switch, and few other components like a variable resistance or some appliances attached to it. So now coming to the basic concept called electric current. So what is this electric current? Electric current is nothing but the flow of electrons in this closed loop of a conductor. So how does the electrons flow? So this closed loop is connected to a power source like a battery or a generator. So here the electrons generated from this power source, they flow in the circuit, and this flowing of electrons makes up the electric current. So now coming to the aspect how to define this electric current, we can just remember the formula I is equal to Q by T. So what is this I? I is the symbol denoted for the electric current, while Q is the charges and T is the time. So I is equal to Q by T. So Q is the amount of charges that is flowing in a closed loop of electric current in the circuit per unit time. Okay, so here if we remember the formula, we can always give the definition of electric current too. So electric current is defined as the number of charges that is flowing in an electric circuit per unit time. So next coming to the concept called a closed loop or a electric. So how is that electric circuit looking like? It consists of a resistor, a bulb, there is a key or the switch, and here we connect the battery source. So conventionally it is considered that the electrons that flow in the circuit is from the positive end. It enters the resistor R. This is the bulb through which the current flows and the bulb glows. This is the switch or the key. So once we switch on this or pull the key, put in the key, the charges start flowing in this circuit. So this resistor is something which controls the flow of electrons. So conventionally it is believed that the electrons flow from this positive end, the current I. The flow of electrons is nothing but the current I. It flows like this and then comes back here. But in actual reality, the electrons means the negatively charged particles. The negatively charged particles, they flow from the negative side to the positive side. Okay. So now coming to the concept of potential difference. So what is this potential difference? Potential difference is denoted by the symbol capital V. So what is this V? It is measured using a unit called voltmeter, and this potential difference is nothing but the difference in the voltages that is present in a closed circuit between different components in the circuit. So now this potential difference is actually denoted by the symbol V, and it is, the formula given is W by Q. What is this W? W is actually work done divided by the number of charges that flows. So this voltage is measured with a unit called, its SI unit is volt, and it is measured using a voltmeter. Next, coming to the part called resistors. So these resistors are the important components in an electric circuits. So there are many resistors that are connected in an electric circuits. The symbol for the resistor is this. It is denoted by the symbol R, and its unit of measurement is ohms. SI unit of measurement is ohms. So these resistors, they are not just one single resistor in a circuit. There are many resistors connected in a circuit. When the resistors are connected one after the other, R1, R2, R3, then it is called a series resistors. Next, if the resistors are connected in parallel, if the resistors are connected in parallel, they are called as a parallel resistance circuit. R1, R2, R3. So when we have to calculate the total amount of resistance in a series, then it is denoted by the symbol RS, given by R1 plus R2 plus R3, while if the total resistance to be calculated in a circuit is connected in parallel, then it is given by 1 by R1 plus 1 by R2 plus 1 by R3. So it can go on depending on the number of resistors in the circuit. Now coming to the concept of Ohm's law. So what is actually Ohm's law? Ohm's law is basically given by R is equal to V by I, the formula, or actually the voltage in any circuit is directly proportional to the flow of the electric current in a circuit. So if the voltage increases, then the current in the circuit also increases, or vice versa. We can say that if the current in the circuit increases, voltage also increases. If the current decreases in the circuit, voltage also decreases in the circuit. So this is equated using a constant called R, which is a resistor. So Ohm's law states that the voltage in a circuit is directly proportional to the flow of the electric current in a circuit, and the formula is V is equal to I into R. So next, coming to the numerical section, where some of the these concepts are involved to solve some numerical problems. The first problem is study the following electric circuit and find, in this first one, the current flowing in the circuit and the second one is the potential difference across the 10 ohm resistor. So the given circuit is, there is a resistor here, there is a resistor here, there is a switch or a key, and there is a battery connected to the circuit. So this is the positive side, this is the negative side. The flow of current is I. This is R1, which is 10 ohms. This is R2, this is 20 ohms, and this is the switch. So in the first part of the question, they are asking the current flowing in the circuit. So the battery source is 3 volts. So the first part is using Ohm's law. We say that we know that Ohm's law is given by V is equal to IR. Now we need to calculate I. So I is equal to V by R. So this I in the circuit, here there are two resistances. So first we need to calculate the total resistance in the circuit, and since the two resistors are connected in series, we are giving it as R1 plus R2, which is 10 plus 20, which is equal to 30 ohms. Now I is the current in the circuit, where the given V is 3 volts divided by the total resistance, that is 30. 1 by 10, that is nothing but 0.1 amperes. Ampere is the unit of measurement of current in a circuit. Next, coming to the second part. So in a circuit we have understood that when the series connection of resistors are there, the voltage splits up into V1 and V2. So here the voltage across the 10 ohm resistor is not the same as the source 3 volts. So this V1 is equal to, current remains I in a series circuit, and the resistance is 10 ohms here. So it is 0.1 into 10 ohms, which is given as 1 volt. So V1, they have asked the potential difference across the 10 ohm resistor. So V1 is given by 0.1 into 10 ohms, that is 1 volt. Next problem is, find the current drawn from the battery by the network of 4 resistors. So the given network is like this. Volt source, and all these resistors are 10 ohms. And this is the switch. So this is the given network. First, to calculate the current, this is V and these are R1, R2, R3, R4. So here we can observe that this R1 resistor is in series and the other 3 resistors R2, R3 and R4 are in parallel to R1 resistor. So the total resistance in the circuit 1 by Rp is given by 1 by R1 plus, since the R2, R3 and R4 are in series, but it is in parallel with the first resistor R1. We will be taking it as 1 by R2 plus R3 plus R4, which is 1 by 10 plus 1 by 10 plus 10 plus 10, which is 1 by 10 plus 1 by 30. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus R3 plus R4, which is 1 by 10 plus 1 by 10 plus 10 plus 10. So this is given by 1 by 10 plus 1 by 30. So here we'll be taking 30 as LCM. So this will be 3 plus 1, which we get as 4 by 30. So 1 by Rp we are getting as 4 by 30. So the total resistance which is connected in parallel is actually 30 by 4. So what is 30 by 4? 4 sevens are 28.5. So 7.5 ohms. Okay, now coming to the second part of the question, where the current drawn from the battery. So what is actually the current drawn from the battery? So I is equal to V by R. V is actually 3 ohms and R we have calculated as 3 volts. Voltage is 3 volts and R we have calculated as 7.5 ohms, which we get as 2 by amps. Next topic, we can also discuss the factors affecting the resistance in a electric circuit. So what are the factors that affect the resistance in an electric circuit? So it is the flow of current, the voltage, then the temperature and the material that has been used to make the conductor or the conducting material. Now the main topic is the circuit diagram. So this circuit diagram is a important question in the board exam. So they include the components that have to be included in the circuit and ask you to draw the circuit diagram. So the circuit diagram mainly consists of battery, which the symbol is this. Here it is plus, this side it is minus. Next comes the switch, which is denoted by the symbol key or this symbol. Okay, and the resistor. By now we already know the symbol of the resistor, and there is a variable resistor, or it is also called as rheostat. Then there is a wire joint, which this is the wire joint. Then there is the ammeter symbol, A plus minus. Ammeter is the instrument used to measure the electric current in a circuit. Then there is the voltmeter, which is denoted by the symbol V, and this is used to measure the voltage in a circuit. Then there is one of the Very common components are the appliances that they connect in a electric circuit, which is the bulb. So these are the few electric symbols which we need to remember. In the exam, they usually ask you, like they give you the list of the components to be drawn in the circuit. For example, they might say draw a circuit diagram, draw a circuit diagram using a 3-volt battery, 5 ohm resistor, a voltmeter, an ammeter, a switch, and a bulb. So the placing of the components can vary. There is no hard and fast rule for placing of the components. It is just that the battery, this is the 3-volt battery, this positive and negative symbol has to be there, and a switch symbol is here. Then comes the 5 ohm resistor, then comes the bulb, and then the voltmeter is usually connected in parallel to the resistance, okay, and the ammeter is connected in the series in a circuit. So this is the electric connection. So these components need not be in the same order. The ammeter can be placed here, so the variations can happen. These changes will not actually affect the circuit. So that's all for today's video. Hope you learned something. You can find the PDF notes of today's session linked in the description box. Use the comment section to choose the topic you want us to cover in the next video. So do let us know. Thank you.